Today we're doing 3.4, 5 through 11 odd, and 21 through 63 odd. I don't think we're going to get through all of it in one day. If I had the quadratic x squared minus 6x minus 18, how do you factor that? There's no x to take out in this case. Well, this should factor into something like this. How do we find those factors? We use the box. We draw the box. Then what? You put x squared in, and you put negative 18 in. Now what? Multiply those together, and I get negative 18x squared. This 18 is negative. What does that negative tell me about the factors? One is positive and one is negative. Does everybody understand that? We are going to end up with x plus something and x minus something. How do I know one of them is positive and one of them is negative? Because 18 is negative. If you take a positive and you multiply them together, what do you get? Positive. If you take a negative and you multiply them together, what do you get? A positive. So if you take a positive and a negative, or a negative and a positive, and you multiply them, you get a negative. So when the last number is negative, that automatically tells you that one of them is plus and one of them is minus. And it doesn't matter where you put them. I have one positive and one negative. Okay? And then I look at the factors of 18. 1 and 18, 2 and 9, 3 and 3, 4 doesn't work, and so on. But this number is negative. What does that tell me about the two factors? We're going to have a negative number and a positive number, and when we multiply them together, they equal negative 18. We take that same negative number and that same positive number, and when they add together, which one wins? When you have a positive and a negative fighting it out using addition, which one wins? It depends on which one's bigger. So in this case, when the positive number and the negative number fought it out, the result was a negative number, which tells us the negative had a higher absolute value than the positive. So in this list, it's small numbers get the plus and big numbers get the minus. Oh my goodness. All right, we need to restart this. X squared minus 6x minus 18. We draw the box. X squared and negative 18. Negative 18x squared. One is plus and one is minus. 1 and 18, 2 and 9, 3 and 6. And we know that the big one gets a minus. So plus, minus, plus, minus, plus. Well, this tells me that they're different. You understand that? If the last one is negative, it's either plus minus or minus plus. Well, the middle number comes from adding those two together. So if I have a negative number and a positive number and I add them, they're going to fight each other. And whichever one weighs more is going to win. So the result is negative 6. I took some negative number and some positive number, and the negative number was stronger, because when they fought it out, I had negative 6 left over. Oh, negative 6 isn't even going to work. I meant negative 3. Sorry. So will one of those sets give me a negative 3? Positive 3x, and it has to be 3x and 6x, otherwise you don't get the x squared. I put in 3x and negative 6x. What does the top row have in common? X. And if I pull out an x from each of those, I get x plus 3. Now if I take an x out of the first row, or first column, I get x minus 6, and then we just double check. Is negative 6 times positive 3 negative 18? Yeah. So my factors are x plus 3 and x minus 6. And I believe 3.4 just says factor. 2 and 9 would make 7. Not right, not 3. Factor, 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 factor. Okay. If the problem said find the roots, what are the roots? We put them both equal to 0 and solve. X plus 3 equals 0. I subtract the 3 and I get negative 3. And then x minus 6 equals 0. I add the 6 and I get positive 6. Okay, let's try another one. Just like before, I stick the x squared and the 35 in the box and I multiply them together and I get 35x squared. Now that 35 is positive. What does that tell me about the two factors? It's either plus plus or minus minus. How do I tell which is which? Well, they need to multiply to be 35, so it's either plus plus or minus minus. And when they add together, they are negative 12, which tells me they're both negative. So we'll put a negative, and my choices, I don't have very many choices. 1 and 35 and 5 and 7. The negatives will give me negative 12. I put negative 5x on one and negative 7x on the other. Does it matter where I put them? No. What does the top row share? X. If I pull out an x, what's left? X minus 5. And if I take an x out of the first column, I get x minus 7. My factors are x minus 5 and x minus 7. Okay. What about this one? Oh, let's do... Can I do anything to this to make it easier? Take out a 2. Right? I pull out a 2, and I get x squared minus 5x minus 50. Then I draw the box, put in the x squared and the negative 50, multiply those, and I get negative 50x squared. That 50 is negative. What does that tell me about the roots, or the factors? One is plus and one is minus, and if I look here, or actually here, I also know that the bigger one gets the negative. When I have a negative number and a positive number and they hit each other, the negative wins. So plus and minus. Factors of 50, 1 and 50, 2 and 25, 3 doesn't work, 4 doesn't work, 5 and 10, and that's it. And I know that the negative goes on the bigger number. Will one of those sets give me a negative 5? Yes. 5 and negative 10. Don't forget, it's 5x and negative 10x. What does the top row share? X. If I pull out an x, I'm left with x plus 5. And if I pull out an x, I'm left with x minus 10. What is my answer? Don't forget the 2. It's 2 times x minus 10 times x plus 5. It's not a 0 root. There's no x there. It's just the number 2. Does that help? Okay. Yeah. So that's a review of what we've done in the past. What if I had this? let's say x to the fourth, and then plus 6x to the third. Can I take anything out of that? No number, but they all have 3 x's. I'm going to pull out x to the third. If I take an x to the third out of that, what's left? X squared. And I take an x to the third out of that one, 7x. And I take an x to the third out of that one, plus 6. Now I can use the box. X to the third and 6, or x squared and 6, 6x squared. Let's make that a plus. My 6 is positive. What does that tell me about the factors? It's either plus plus or minus minus. And then I look here, and the middle term is positive, which tells me they're both plus. My options are 1 and 6 or 2 and 3. Will one of those give me a positive 7? 1 and 6. So plus 1x and plus 6x. Top row shares an x, which yields x plus 1, and the left column is x plus 6. Yeah, I switched it, sorry. My answer is x to the third times x plus 6 times x plus 1. Does that make sense? I pulled out what I needed, and then it simplified down to a quadratic, and then I just used that quadratic and factored. Okay. What if I had this? Can I take anything out? I can't. The 36 doesn't have any x's. Well, there's actually another way to do this. It might look like it's missing something, but let's pretend that it said x squared and x and then 36. So let's pretend that it's x squared minus 13x plus 36. If it was, can you think, well, can we fill this in? The 36 is positive. What does that tell me about the factors? They're going to be positive. Or sorry, they're either both positive or they're both negative. If I look here, they're both negative. So I have x minus and x minus. Are there factors of 36 that add to be negative 13? One and 36. 1 and 36, they don't work. 2 and 18, that doesn't work. 3 and 12, that doesn't work. 4 and 9, that's it. So x minus 4 and x minus 9. But that's not totally true, right? What's wrong with what I've done? I forgot about the other exponents. So is there something I can do to this so it equals x to the fourth? Well, I could make it x squared minus 4 and x squared minus 9. Does that make sense? So x squared times x squared is x to the fourth, right? And then negative 4 and negative 9 make a 36. And then if I multiply this one, I get negative 9x squared, and this one is negative 4x squared, and I add those together, and I get negative 13x squared. So you can pretend that an equation is a quadratic as long as, oh no, whatever. You can pretend that the equation is a quadratic as long as this exponent is twice as big as that exponent. If the first exponent is double the second exponent, then you can factor it even though it's not an x squared. But do you remember these? How do we factor a DOPS, a difference of perfect squares? X minus 4, x squared minus 4. How does that factor? Yep, we take the square root of this, and we get x minus 2 and x plus 2. Do you guys remember that? And then x plus 3 and x minus 3. Yeah. If it's x times x minus something times itself. So this is x times x minus 2 times 2. X times x minus 3 times 3. If it didn't have a squared, then you'd be done. Yep. And x squared plus 4 doesn't work. It has to be a subtraction. The reason is, when I multiply these together in the box, x minus 2 and x plus 2, I get x squared minus 2x, 2x, and negative 4. And those cancel. Does everybody see that? Okay. Oh my goodness. I don't know what's going on. Oh my goodness. It's not my day. What about this problem? Let's do... Oh, oops. Minus 5x. Uh-oh, hang on a second. No, that won't work. Minus 21x. Nope, that's not going to work either. Okay. So, is the first exponent twice as big as the second exponent? Yes, so we can use the box. Put in x to the fourth and negative 9. X to the fourth times negative 9 is negative 9x to the fourth. Are there factors of negative 9 that add to be negative 8? Well, this sign is negative, which tells me one is plus and one is minus. And this one tells me that the bigger one is negative. So 1 and negative 9. Will that work? Yes. But it's not 1x. It's 1x squared. And negative 9x squared. What does the top row share? Oh, did I do this wrong? I did. Oh well. Well, I wanted this to be a plus. Sorry. I end up with x squared minus 1, and x squared plus 9. My factors are x squared minus 1 and x squared plus 9. Can I take those any further? Can I take the x squared minus 1 further? Is it something squared minus something squared? Yes, x times x minus 1 times 1. So this ends up being x minus 1 and x plus 1. What about the other one? Good. The other one doesn't work because it's a plus. If it was a minus, what would I write? X plus 3 and x minus 3. But it doesn't factor, which means I just put it like this. I do not know why this isn't working. Let's try this. All right. What about this? Can we use the box on this? Yes. How? We have a 6 and a 3. The 6 is twice as big as the 3. I draw the box. X to the 6th and negative 20. Negative 20, x to the 6th. This number is negative, which tells me we have a plus and a minus. This sign is positive, which tells me the bigger one gets the plus. 20 has factors of 1 and 20, 2 and 10, and 4 and 5. Will one of those give me a positive 8? Negative 2 and positive 10. But I put negative 2 x to the 3rd, and then 10x to the 3rd. What does the top row share? X to the 3rd. If I pull out an x to the 3rd, I'm left with x to the 3rd minus 2. And then down here, I get x to the 3rd plus 10. My factors are x to the 3rd minus 2 and x to the 3rd plus 10. Do those go any further? No, they're not perfect squares. It would have to be x squared or x to the 4th in order for that to work. Okay, that takes you through the first set. You factor the first set. So that is 4 through 11. For the next set, it says factor the polynomial completely. I want to do number 24. So m to the 3rd minus m squared plus 7m minus 7. This is eventually going to be factored into 3 sets of parentheses. Okay? And I know that they all start with m. And what do I know about these numbers? Those numbers have to go into, we did this, wait, maybe we haven't done this. Sorry, I'm in the wrong place. So, for the next section, we are going to do what is called factor by grouping. Now, factor by grouping doesn't always work, but in this section, it will. Factor by grouping means we have an m to the 3rd polynomial, and we put these two in a group, and we put both of those in a group. What does that first group have in common? M squared. I write down m squared, and when I pull out an m squared from both of those, what's left? M minus, I took everything out, so what's left? 1. Okay, and then here, what can I pull out? If I pull out a 7, what's left? M minus 1. Now, if factor by grouping works, it's easy to tell because this and this are the same. Now, what does this have in common with that? They both have an m minus 1. So I'm going to pull the m minus 1 out from both of those. If I pull out the m minus 1s, what's left? M squared plus 7. Does everybody understand that? Okay, let me do another one. Two k to the third minus 20k squared plus 5k minus 50. I have an x to the third that has 4 terms, so I check grouping. If I group those and I group those, what does the first group have in common? 2k squared. 2k squared. If I pull out 2k squared, what's left? K minus 10. What does the second group have in common? 5. I pull out a 5. What's left? K minus 10. See that? All right. Now, what does this have in common with that? K minus 10. I yank out a k minus 10, and what's left? 2k squared plus 5. Do you want to see another one of those? We good? All right. And then I just want you to go to 37 today. So you'll do 5 through 11 odd. And then the rest of it is 21 to 63 odd. But I want you today to stop when you get to 37. Do number 37. But before you do that, what if I had this? 9x to the fourth minus 25. Can I pull anything out? No. But is this something squared minus something squared? Yes. So what is the square here? 3x squared and 3x squared. 3x squared and 3x squared. What's the square there? Minus 5 and plus 5. Does that make sense? Okay. What if I had x squared minus... Ooh, let's not do that. X squared minus... x to the fourth minus 16. How is that going to factor? Is it something squared minus something squared? Yes. X squared minus 4 and x squared plus 4. Can I go further than that? Which one? Just the left one. Why not the right one? It's positive. This one will become x minus 2 and x plus 2, and this one just stays as it is. Okay, so 5 through 11 odd, and then 21 through 37, stop there, and we'll finish the rest of this on Monday.